Hello and welcome back to the Great British Bake Off. I'm your host, Ginger Jam, and I'm jazzed because it's Chemistry Week in the tent. Now, let's meet our bakers.
First up, we have Graham Cracker. Graham lives in the Scottish countryside with his 8 children, wife Petunia, and beloved sheep, Pineapple. Next, let's introduce Dr. Coco Powter. A thriving 27-year-old, she recently earned her doctorate in yarn pulling from the Royal School of Needlework. Our last contestant is Olive Oil. Travelling all the way from the southwest corner of Nice, Olive is excited to be in the tent. She lives with her husband and cares for her 2 young children while running a coastal cafe.
Bakers, for this week's Showstopper Challenge, you will have 2 hours to create a dish with unique chemical properties. Aside from that, you have complete artistic liberty. 3, 2, 1, bake! Cheerio, Cracker! What are you up to right now?
Well, right now I have water boiling before I add my gelatin. Gelatin is made from a protein called collagen, which is made up of amino acid chains that bond to form a triple helix structure. When mixed with boiling water, the increase in thermal energy causes the bonds between the amino acid molecules to break down, resulting in single protein chains.
Wow, that's so interesting. What do you do after boiling the gelatin?
Well, then I mix in cold ice water and pop the mold into the fridge for a bit, for the gelatin to set. Once the solution cools, the protein chains will be able to bond together again. However, the newly added water molecules mix in between the chains, obstructing the protein molecules from being able to bond together again, and preventing a perfect triple helix from reforming. The imperfect helix is what gives the jello its signature jelly state.
Wow, that's amazing. So, is jello a solid or a liquid?
It's not quite either. It's a state called a colloid, which is the substance formed when small particles are dispersed in a solution.
Wow, how fascinating. So many particles in a small container. Well, best of luck to you, Cracker. Hello, Dr. Coco. Looks like you've made some good progress already. And what is this? It looks alive.
Yeah, so this is my sourdough starter, Anita. To make a sourdough starter, all you have to do is combine flour and water. The yeast and the bacteria naturally found in the flour and in the air feed on the sugars in the flour, and by day 3 of waiting, lactic acid bacteria lowers the pH to about 3.5, and the acidic conditions they create kill off all the other microbes, little buggers, except for the lactic acid bacteria and a few acid-tolerant yeasts.
And so, what happens after the starter has reached this state?
After about 10 days, Anita stabilise and the yeasts and the lactic acid bacteria spontaneously grow vigorously and produce enough carbon dioxide to leaven a loaf of bread. Making a sourdough starter increases entropy but doesn't specifically produce heat, and instead it requires warm temperatures to go. So for this reaction to be spontaneous or have a negative delta G, it requires warm temperatures.
Oh wow. So what do you do after the dough is made?
When you knead the dough like this, the yeast metabolize the simple sugars, resulting in starch breakdown and carbon dioxide and thermal energy through a process referred to as alcoholic fermentation. Then you proof the dough. The microbiomes continue to eat the sugars in the flour and produce more CO2 as a byproduct. And finally, during the baking, application of the heat brings the expansion of the CO2 and the evaporation of ethanol, causing the bubbles of sourdough.
Wow, This is such a fascinating process. It seems like you have a really good understanding of the chemistry behind it.
Thank you.
Well, best of luck to you and Anita.
Thank you.
Bonjour, Olive.
How's everything going over here?
Mon Dieu, I'm lucky the tent had half and half in stock, or else the ice cream would not emulsify.
Oh, interesting. And why is that?
Ice cream contains polar and non-polar components. The non-polar part being the ice cream in the half and half, while the polar part comes from the sugar molecules. Normally, when these two substances are mixed, they separate from each other. However, milk molecules in half and half have polar and non-polar ends, so they bond to the ice cream and sugar, helping them combine without separating. This is called emulsification. If I just use the cream, the ice cream would not be creamy or soft.
Wow, I didn't know any of that. And why is it so important to keep ice cream in a cold place?
Ice cream has both dipole-dipole and hydrogen intermolecular forces. Energy is required to break these bonds. Temperatures above 0 degrees Celsius have enough thermal energy to overcome these bonds between ice particles. This results in the ice cream melting into a liquid.
Wow, how cool. Well, best of luck to you, Olive. I'm excited to see the finished product.
Thank you, thank you.
Bakers, want to hear a joke about nitrogen oxide?
No!
Alright, since you don't want to hear it, I'll let you know that you have 30 minutes left in this challenge.
Oh my!
This is my secret ingredient, pure maple syrup.
Bye, Anita. Be safe in there.
My jello isn't set.
What's going on over here?
My pineapple jello won't set.
Oh, well, pineapple has some interesting enzymes, don't you know?
Oh my god, how can I be so stupid? The enzymes in the pineapple are breaking the collagen chain, stopping the jello from setting. Oh dear, how much time do we have left?
About 5 minutes, I fear.
I'm just gonna have to make do with this.
High fructose corn syrup?
This is American?
Oh, those stupid Americans! My ice cream is ruined. I'm ruined.
Stunning. Isn't she gorgeous?
Bakers, time's up! The dishes will now face the judgment of Pauline Hollywood. Well, it seems like we have quite the spread here. I can't say I'm exactly impressed with all of these, but let's give it a try. Cracker, I think it seems that your jello hasn't set at all. I just don't think this is edible.
I'm deeply sorry.
It's very, very sweet. And like you said earlier, very firm. You know, as someone who specializes in making ice cream, I'm kind of disappointed in you, Olive. Wow! I've never seen a loaf like this! It's positively gorgeous and even more scrumptious. Well done, Dr. Coco. Bakers, we have determined that this week's star baker is Dr. Coco! Congratulations!
We did it, Anita!
As for the rest of you, I think it's time to go back to chemistry class.